Hauxin and I are gonna present the topic Iceberg to meet AI work. Yeah, Hauxin is actively working on Apache Spark and Apache Iceberg projects. Yeah, my name is Aihua. I work on Apache Hive before, and currently working on Apache Iceberg, mainly focused on variant actually. Um, so uh, for today's agenda, we're gonna talk about the challenges in AI pipelines. Mostly, we focus on AI data. How do we solve, like from Apache Iceberg, right? How do we solve the data issue in AI? Second, we're gonna have an overview for Apache Iceberg. We're going to talk about the key features right now in Iceberg, which can meet AI, how to scale AI. And then especially, we're going to talk about some like data types, like, variant data type, those kind of things, which could like serve AI workloads. And we're going to also talk about some incoming work in Iceberg project. So yeah, this is kind of like a give very actually this is like drawn by AI, but it's still have a lot of things to improve. I kind of like keep trying and to get it to work. So yeah, so basically this is like a high level pipeline. So one is first like it's crawling data, ingesting data, and then we do some like data engineering to clean the data. Then we're going to come into a loop into training and evaluation, then kind of like serving the model and then monitoring. And now for this pipeline, there's like data flow, right? Regarding the data, it's going to be have, like data ingestion, like to ingest or crawl the data and into the table. And then we're going to prepare and then do clean the data for model training, and then we're gonna generate the feature stores. And then later, and then we're gonna generate the model artifacts and the metadata to serve the model. Then it's kind of like online serving. So I kind of like list some of the challenges in AI pipelines. One is data quality. So let's say if the data is not clean, right? Then definitely like the model you get trained will be not as good. So yeah, for my personal experience, when I doing my research, I'm focused on, let's say, signature verification, which is for forensics research. We collect the data, but at that time, we collect data from students' signatures, but we don't have experience, to sign, right? Then the data is not very, it's not very good. Then the model you trained will not be good, right? So you need to reach out to more broad users to collect those kind of data. And also you can think of like, you need to have a better way to clean the data. For example, if there's a missing values, or if it's not a good data, then you should clean that. Now, Iceberg has a better way how to do, like you can delete the data rather than rewrite the files, so those kind of things. And also, like in AI pipelines, how can you version in that data? Now, actually, before you don't have a very good ways in, let's say, Hadoop world, you don't have a very good ways. But with Iceberg, you can provide a versioning to reproduce the model. The third one is like scalability. With like, especially with generative AI, right? The data is huge. How can you scale the training? The fourth one, like privacy security, it's always kind of a concern, right? You don't want your social security number to be in a training model. You can. How can you mask those kind of models, also kind of data column? The following are like a model testing, validation, monitoring, and maintenance. This is kind of like challenge, definitely like how do you validate the model will be a challenge, but I just called it here. It may not be solved by Iceberg, but it's a challenge. Yeah, I'm kind of calling out the data types, especially for data types. AI can have structured data, semi-structured data, unstructured data. For structured data, for example, I have done like pricing optimization. Basically, for Walmart, you want to do like pricing forecast, right? What time you want, how much you want to mark down, how much you want, when you're going to mark down, so certain kind of price. So based on the historical sales, you want to do this kind of forecast. So typically, those kind of data are well structured. You can model this with structured data and then to do the model trainings. Now for semi-structured data, like JSON or HTML or those kind of data, like right now, you kind of like pull the data from internet and then you can model this, use semi-structured data and then to do the training, especially like for search engine, right? Like a Google or some other engines. Unstructured data, for generative AIs, that's very common. Like, for example, the images or videos, you want to generate videos, you want to use the videos to do the training, right? How do you model those kind of, how do you store and model this kind of unstructured data? That's also kind of like challenge in AI. Now coming back to Iceberg, I kind of listed the features in Iceberg. And then we're going to see how Iceberg can meet AI need. So Iceberg, yeah, actually, like before that, like Julian is talking about Apache Parquet and Chao is talking about Spark. Actually, for our topic, it's kind of like in the middle. Like Parquet and Spark, and we are in the middle of like table format. Iceberg is kind of like open source table format, which kind of you can plug in different format like Parquet or Avro, to Iceberg can have like standard to serve the queries from different engines, Snowflake or Spark. It has a built-in ACID transaction, which can make sure the data will not be corrupted. We can serve multiple writes at the same time. And we also have like hidden partitioning functionality, which can, well, actually, in the old world, for example, Apache Hive can only support physical partitions, but Iceberg can support logical partitions. Later, we're going to talk on more details about this, which will be very flexible. And Iceberg also support a schema evolution, which is very common for AI data. Like you evolves the data, the data always evolves. You add the column, you delete the columns. Iceberg can handle that with schema evolution without any issues. You don't have to rewrite the data, repeatedly. Iceberg also use a snapshot to track different versions, and then you can roll back the data or travel back to the old versions. And remaining, Iceberg also have performance in mind when it's doing its own implementation. Lastly, it's an open source. It's an open source table format. Like a lot of engines support that, like Spark, Snowflake, and a lot of engines. So it's more like compatible. You can switch between engines without any issue. Now, for AI to meet table format, so for AI, like we need a reliable version data structure, right? To you can reproduce the model trainings Or if you see the regression, you want to go back to the older versions. And also, you can like time travel back to the old versions to debug the model model drift if you see the regression. With this kind of snapshot versions, we can also like without train with all the data, we can do the incremental trainings. And the training data also changes frequently. We can use the schema partition evolution to do the model trainings. And also, again, like data pruning with rich metadata, and also like multi-engine freedom, right? So for different states, you can choose the best engine to do the trainings. Clean data ingestion. So this is talking about, how when you ingest the data, right? You want to have, one is you want to track the source data. So you can append the data, raw data, and then you can always go back to see what is your original data. And we can also have additional steps to do the cleaning with like ACID or those kind of operations to guarantee the data is not corrupted. And then you can add like a metadata to trace the model and to pin certain versions. And then you can do like temporal partition and also enable clustering to improve performance. Data versioning. So I can repeat that. So we use like snapshot to keep track of the versioning. Then you can go back to the older versions and to reproduce the model. Again, this is kind of increment data sets, right? Like you don't have to like, it's also more for to improve the performance. You don't have to train the whole data set. You can find the diff between these two snapshots and then to do incremental trainings. For schema partition evolutions, this is more like, like if you want to add additional features, like with schema evolutions, you can keep the old data, which will be like null if it's new columns. And then you add new columns. You can add the new columns with schema evolution. And also like for if you want deprecated features, like for example, to remove sensitive data or unused data features, then you can drop the columns without affect the old data. Same thing for like type corrections. For example, before it's integer, right? Right now you think it's like float or long, then you can do the type of promotion. And for hot partitions, so that is like, if you notice like the queries are low, you can, like add partitioning to logical partitioning to the new data without affect the old data. So with that, actually, like with the future queries, you can apply partition evolution to prune the data, then to improve performance. I think I'm gonna stop here, and Hauxin gonna talk more on the Iceberg features.
Thanks, Aihua, for the first part. I will continue with the rest of the talk. So I will continue with the partition. So let's take a look at the Iceberg performance at scale. I will start with partition. So in Iceberg, we can do the temporal partitioning. So for example, when we create a table, we can partition the table with the days. The benefit of this is that we can do partition pruning. So for example, if we say we want to, if we say, give me some data for this specific days, and then for the partition which are not within the days range, for the partition can be pruned off. So as a result, the engine will skip reading chunks, big chunk of data. So the query will be very fast. Sometimes one dimension of a partition is not enough, and then we can add multiple dimension. For example, as you can see in the table, we can not only partition on this, and we can also partition on the product category. The iceberg partition is a logical partition. It's not a physical one. So when you do the partition column, it doesn't need to be a physical column in the schema. The good thing about the logical partition is that you can do partition evolution very easily. So for example, initially you can partition by this, but later on, if you find out partition by this is not sufficient, we can just switch to partition to time very easily. I will talk more about the performance features. For example, in Iceberg, we can align the sort order with the filters, with the filter column, and also align with the join keys. This can make the query faster. And also in Iceberg, we can compact the small files into the suitable size of files. This can also improve performance. In addition, we can do column pruning, we can do filter pushdown, and this can let the engine read much less data to improve the performance. One thing I want to talk about is that we integrate a Comet with Iceberg recently. So Comet is a native execution engine. So basically, Comet can convert the Spark physical plan into the native data fusion plan. And then the plan can be executed in native space. And this can improve the performance a lot. I also want to talk about the unstructured data because the unstructured data is really important for AI and machine learning. Iceberg has added this variant data type recently. So basically, the variant data type is a semi-structured data type. It can hold objects, arrays, scalars. For each row, the shape of the row can be a bit different. The motivation of the variant data type is speed. So in day one, we can land a flexible payroll fast without arguing of defining a perfect schema. So later on, if it turns out some of the field in the variant is very useful, we can promote this field into typed columns. If you want to use a variant, you need to use type 3, I mean version 3 Iceberg because it's only supported in version 3. In variant, there are a bunch of JSON functions and also variant functions. You can use this function to access the fields inside the variant. So this slide shows how variant can help AI and ML. So during the injection time, we can just inject the payrolls very fast. And later on, during the feature evolution, if it turns out some of the features are really useful for the model training, we can promote this field into a typed column. So this variant data type can coexist with the regular typed column. It gives us a lot of flexibility in the beginning when we're exploring the data. And later on during production, it can give us the speed, the performance. I also want to talk about this unstructured data a bit because this is really important for AI and machine learning. Currently in Iceberg, we don't have a data type to specific for this unstructured data. but there has been some discussions about this blob data type. So this blob data type can be used to manage large binary data. It can use for image, audio, video, or PDF. There are two kinds of representations. We can save it out of line. For example, we can store the URIs and the descriptions in Iceberg. And for the heavy media, we can save them in the object store, such as S3 or Google Cloud Service. For the small data, such as the thumbnails and the snippets, we can save it inline for the binary format. I have a few more slides talking about the future of the Iceberg, but I think I don't have the time's up, so I will just stop here. Yeah, thank you very much for listening.